These are the notes for section 7.3, similar triangles. The objectives are I will be able to identify similar triangles, and I will be able to use similar triangles to solve problems. Section 7.3 talks about 3 different ways to prove that triangles are similar. They are pretty comparable to what we did before with congruent triangles. With congruent triangles, we learned about 5 different ways. So with congruent triangles, we learned about side, side, side congruency, side, angle, side, angle, side, angle, 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 side, and lastly, hypotenuse leg. So these were ways we could prove that triangles were congruent. With similar triangles, we will typically write a similarity sign after it. So we have just 3 ways to prove that triangles are similar. The first is angle, angle, similarity. The second is side, side, side similarity. And lastly, we have side, angle, side similarity. And you'll see that these 2 things are pretty well related. So even if you struggled with congruent triangles, here's another chance where we're going to reinforce that knowledge with similar triangles. Remember, with congruent triangles, we had the exact same length, but with similar polygons, we have proportional lengths. The first one doesn't talk about side lengths at all. It talks about 2 angles, angle, angle similarity. This says if 2 angles of one triangle are congruent to 2 angles of another triangle, then the triangles are similar. So what we could say is, we could have angle Q congruent to angle S, and angle P congruent to angle T. So we have 2 angles that are congruent on each triangle. So we could say triangle QPR is similar to triangle STU. So remember, this symbol right here from our prior lessons, you should remember means similar. So we have side, side, side similarity also. This says if the measures of the 3 sides of 2 triangles are proportional, then the triangles are similar. So if I wanted to do this one, should be able to see that A over AX is equal to B over BX, which is equal to C over CX. Whenever I would simplify this, I could see that I could just get rid of the A, B's, and C's, and they're all equal to 1 over X. So these would be similar triangles. The sides are in proportion. All 3 fractions simplify to 1 over X. So if I was coming up with a similarity statement, it would be triangle PQR is similar. That's the one that goes A, B, C. Is similar to TSU. So triangle TSU. The last way we had to show triangles were similar is the side angle side similarity. This says if the measures of 2 sides of a triangle are proportional, to the measures of 2 sides of another triangle and the included angle. We spent a lot of time talking about the included angle. That's the angle between the 2 sides. Then the triangles are similar. So remember, the included angle for triangle QRP would be angle R. That's between A and B. And the included angle is S on our other triangle because it's between SU and ST. So we have the included angle, and we need to make sure that the sides are in proportion. So again, just like above, we take A over AX, and we see that that's equal to B over BX. And again, whenever we simplify it, we see that it's equal to 1 over X. Now let's take a look at some examples. We're going to do the evens. I want you to try the odds. In an attempt to save some room, I'm going to take away the odd ones to give me some more room. But I want you to try them. So for number 1, or sorry, for numbers 2 and 4, it says determine whether each pair of triangles is similar. So determine if they are similar. Justify your answer. If the triangles are similar, write a similarity statement. So if the triangles are similar, we write a similarity statement. Well, I take a look at number 2 and I see that I'm given no angle measures. There's no congruency marks or anything like that. So this is a candidate for side, side, side similarity. I'm given 3 side measures. So I take the smallest side, 8, and I'm going to put it over the small side in the other triangle, 6. So 8 over 6 is equal to 12 over 9. I'm using that triangle on the left on top. The triangle on the right goes in the bottom of the denominator, and that's equal to 12 over 9. All of these, when I simplify them, will reduce to 4 over 3. So every single one of them. So these are similar. Why? Because we have the side, side, side similarity. Our statement, since I color coded, I could just do black to red to blue. So that would just be triangle ABC is similar to, remember we went black to red to blue, so we go black to red to blue, so that'd be PQR. Let's try number 4. These look like they should be similar by side angle side similarity. We're given the included angle, which are S and J, which are the same, and I have the side surrounding it. So the short side is 10 over the short side 15. Does 10 over 15 equal 14 over 21? These both simplify. This goes to 2 over 3, and when I divide everything by 7, that goes by 2 over 3 also. So the sides are in proportion. I have the included angle, so that means they are congruent by side angle side similarity. And once again, I can just do black to red. So it would be triangle. So we go black to red. That's TSU is similar to triangle black to red, PJM. So again, make sure you try numbers 1 and 3 on your own. Again, I want you to try the odds. So let me take care of this. So make sure you try 5 and 7. And we're going to worry about 6 and 8 on this video. So the directions say each pair of triangles is similar, and we're asked to find X and Y. So let's start off with Y. So I have 20 over Y, and the sides that it's going to be congruent to, or sorry, proportional with, is 26, and this is the number one mistake people make. A lot of people say 13, but I have to use this whole entire side. I'm looking at the large triangle. So this side is 26 plus 13, which is 39. Now I'm ready to cross multiply it and solve it. So whenever I cross multiply it, I get 26y is equal to 39 times 20, which is 780. When I divide by 26, I'll get y. So remember, I can just scroll up and hit enter, and y will be 30. So I found y, now I just need to find x. And I'll erase this to make things a little clearer for x. X is really easy. We can try to make it complicated by making a proportion, but we should see we have two lines, so these two lines are going to be congruent. So x plus 2 is equal to 26, and whenever we subtract 2, we get x is 24. We could make this a lot more confusing with a proportion, but I really don't want to do that, and I'm sure you don't either. The last one we have is number 8. So again, we have to find x and y. Let's start off with y because that one's pretty easy to find. We just do y over 22 is equal to, the sides that we have are 30. That's going to go up with y because it's the same triangle. And again, it's not going to be 10, it's going to be this whole side right here. This is 30 plus 10, which is 40. So we have 30 over 40. Now I just cross multiply them. 40y is equal to, this is going to be 660. That's what 30 times 22 is. When we divide both sides by 40, we have 660 divided by 40. We get 16.5. So that means y is 16.5. Now we're going to solve for x. So with x, that's this side right here. I'm going to start off with my small triangle. My small triangle has 32 over my larger triangle. So that's the whole side. So this side here is 32 plus x. And I'm just going to keep the same thing that I had before with my blue side. That was 30 over 40. When I cross multiply this, 32 times 40, let's get the calculator to make sure, is 1280. So 1280 is equal to 30 times 32 plus x. I wanted to write this out because a lot of you forget to distribute. Whenever we do this, we get 1280 is equal to 660 plus 30x. Sorry, that's 960. To get x alone, I need to subtract 960 from both sides. So we get 320 is equal to 30x. And whenever we divide by 30, we'll get our final answer. So we do 320 divided by 30. And since that's a fraction, we'll turn it into since that's a decimal, we turn it into a fraction. So x is just 32 over 3. So I think you should be able to try those odd numbers out. Just remember, the same triangle goes on the top. The sides that are in proportion go on top of one another. and I think you should be able to make all of your proportions properly. Please come to class prepared with any questions.